I am senior expert at everis technology. And, as a senior, what's a senior expert? Well, you are like an expert in some kind, okay? So I am an expert back in my time we called ALM, which was application lifecycle management, and now suddenly it began to be DevOps. I have been doing this for more than 10 years because I was always more attracted to this kind of, to the processes and the deployment of the software than to programming, okay? Even if my primary background, my main background back then was a Java developer, and well, it's not something to brag about, but we have to start at some place, okay? So what's everis? Everis is a very, very big company with around 20,000 employees, and who develops software for another clients or customers which are much more bigger, okay? They are like the same or bigger. So traditionally, this kind of companies didn't really, it was not really easy to get the open source software that was being developed by a community and put it in this kind of customers. They wanted the traditional providers. They wanted software from Oracle, from IBM, from this kind of, from Microsoft, this kind of traditional providers that are very big also and such. So this is kind of changing. The point is that everis, it's not just one company that goes aligned like all the product companies or the startups we have been watching during these 3 days in this stage. Okay, it's not like one thing. It's a lot of. It behaves like a lot of sub-companies which are mostly independently managed and with very, very different levels of maturity, engineering maturity levels, from one project to another, okay? So in everis we have probably all the level of maturity through all the projects in the company. And to illustrate this, I wanted to tell a story. I indulge you to let me tell you a story, okay? It happened to me some years ago. I went to a project who was, had problems with their deployment, or that they said, okay? They have a lot of problems with their life cycle. They have a lot of issues in production and such. So I went there to see what was that problem, okay? So I sit with a guy which was managing the deployment for this project, and show me what kind of life cycle do you have, okay? So he opens his Eclipse IDE, and he makes a little change, okay? Compiles a WAR application, which was deployed on a Tomcat in the infrastructure of the customer, and then instead of getting the WAR, he goes to the file system in his machine, uncompress the WAR file, extract the point class file he has just modified. He went to FTP. He opened FTP to the production server, and went to the exploded WAR file on the work directory of the Tomcat, search for that .class which was there, and replace one for the other, and then restart Tomcat. So I was, what? No, but what have you just done? So, man, I'm here. I'm the senior. I'm the senior expert. So you are. How can you do this just in front of me? Keep some dignity or something like that. So this was some years ago. I hope this does not happen anymore. Okay, but illustrates very well what kind of bottom level we can count on, okay? So normally is that the projects do not have internal knowledge, okay? They don't know they need this kind, or their lives can be improved through this kind of software engineering practices. And it's also complicated because when you explain to them how they can improve their lives, then they always go to a thing which was more a thing a couple years ago, but now it's less of a thing because of the establishment of the public cloud. It's the infrastructure, okay? So I cannot do this kind of life cycle. I cannot have a Jenkins. I cannot have any kind of continuous integration server because I don't have infrastructure available. And in this kind of big companies, normally, in this kind of consultancies, normally are the customers who provide the infrastructure for the projects, okay? And it's not that this kind of customers do not have infrastructure, okay, in their own data centers, in their own clouds, or even in the public cloud. It's just that the approval process to get access to some resources is so long that for most of the life of the project, the infrastructure does not exist. So even if you know that you want to do this kind of life cycle engineering, it's not that easy. For short projects, even, it's a real issue. For some projects, the project is finished before the development infrastructure arrives, okay? So to try to fight with all of this, both the customers and both the traditional consultancy have been embracing much more agile processes, okay? So the point is now more traditional companies, even banking, very big banks, are not feared anymore about the public cloud. Okay, but we are talking that this has been happening from 1 year and a half to now. So the maturity on the cloud of this kind of companies is not very big, but they have a lot of resources, so they are putting there very, very fast. Okay, so inside everis we have had a multi-year implication with ALM, because at the end, what we do is software, okay? So we develop software for another companies, and we need to do it good. Because if little companies with very few people are able to launch products a lot of people love to use, why could not us do that, okay? And we need to fight all the stuff that surrounds the bureaucracy, all this kind of thing, and sometimes myths that take on account that the big companies cannot do some stuff. Okay, so as I was saying, this was a multi-year engagement, which has passed through a lot of technologies, okay? So the only thing we have clear from the beginning was the key DevOps concepts, okay? So all the pipelines should be, all the software development life cycle should be based on these 5 principles. And these 5 principles, even when DevOps was not a word, okay? We were trying to apply them with the technologies available at that time. So they are infrastructure as code, which is completely key, okay? All 5 are important, but this, for me, this one is the most important one to a DevOps life cycle, because it empowers the developers, okay? So most of the time here in everis, the dev and the ops teams work separated, but not just, mostly not like in product companies, okay, where they go to the same product. In our case, normally the operations guys are working in operation projects and the development guys are working on development projects. So the point is that tearing apart that wall, it needs a very big culture change, which has not been, we are not there yet, okay? We are working through that, but well, we are trying to change that culture. And the point is that if you don't have op guys available, okay, for at least during the development of the project, the ops guys will only enter for the production infrastructure, the production deployment and such. Then let empower the developers. And how do we empower the developers? Well, with infrastructure as code, treating infrastructure as code. Who do the developers know to do? Well, develop software. So develop infrastructure, okay? But then to achieve that, we also need programmable infrastructure, okay? So developers love APIs, how we saw, I think, 2 days ago. And if they can use a programming language and all the infrastructure is abstract through APIs, okay, everything is much more easy for them. Also, of course, which is in the middle, but I think because it's of capital importance, is immutable infrastructure. All the problems, all that weekends working until the 8 of the night, and because something is failing in production and we are not able to reproduce it because whatever. No, but the whatever is that, whoopa, well, the talk was not that boring. So I think, never mind. So we cannot reproduce the errors in production, in pre-production, because there are two completely different environments. One time, back in the beginning of the project, maybe 1 year ago, the infrastructure was set up by maybe some operations guy who set up the pre-production server and the production server, and then the developers began to put new libraries, to install things in the pre-production machine, and they are trying to keep up pace in a document of the changes in this machine to replicate, to ask the ops guys to replicate it in production and such. But, well, human errors happen, shit happens, and someone forget that he did something on the pre-production machine, and then it is not equal that the production machine. And when the time is passing, then both machines will evolve completely different. And then you will have two completely different machines with the two issues, and that's unmanageable, okay? So for us, even before Docker, okay, immutable infrastructure was a very important concept. Then, of course, the shared infrastructure. So we can avoid to go through all the hardware approval process, okay? And the hardware reaches earlier to the projects. If some hardware has some spare space left, because another project is not making a full use of it, then this project can benefit from that without needing to buy more hardware, which is not normally a money problem, okay? It's much more a bureaucratic problem. And last concept, which was, well, very known to the DevOps community, but I think little known outside or lesser known than the other four, which are the source code pipelines. Okay, it's like applying infrastructure as code to our building pipeline, so we can have reproducible and we can treat it like code. So during the years, we have done some approaches, and I want to share them with you. Okay, how using the technologies available at that moment, we were able to deliver this to deliver value to the development teams. Our first approach was many years ago, well, in our world, maybe 5-6 years, okay? Where Docker was not a thing yet. And well, later. So we tried to find technology to implement those 5 principles, okay? So to implement infrastructure as code in this first approach was done with virtual machines because of the requirements of the server immutability, okay? And for infrastructure as code, we were using Vagrant. Vagrant was a very hot tool in that moment, okay? And it let you spawn customized virtual machines, which can then be stored in a centralized repository. So it was like awesome, okay? And it had a very nice integration with Chef, where Vagrant and Chef, well, the Chef cookbooks could be installed from Vagrant and such. So you can just define the infrastructure, the virtual machine using Vagrant, and you can configure it using Chef, okay? I still have in my GitHub, if you search, I still have some of the old cookbooks we were working back then. It is a nice, well, kind of a relic now, okay? So then the kind of course, the infrastructure immutability, okay? So only virtual machines and no SSH connection to that virtual machines. Everything is done from outside, from Chef or from Vagrant or from anything else, okay? We didn't get there yet with the build pipelines. Normally, I always use Jenkins for continuous integration server. And back then, well, Travis, I think it did not existed. Circle, of course, no. Drone didn't exist, okay? We didn't have a real choice of continuous integration servers back then, because always everybody was using Jenkins. Okay, so we used back then the build pipeline plugin, which is not the current pipeline plugin. It was all graphical, so you can compose a pipeline based on relationships between Jenkins jobs. But that Jenkins jobs must be done by point and click into the GUI interface. And it was not, we didn't like it very much, okay, but we did not find another kind of tool. And the feature we liked is that this pipeline was stored, all the jobs and the relationships were stored in a single XML file that you can take from your Jenkins instance and take to another Jenkins instance, or store it in a Git server or whatever, okay? And then for programmable infrastructure, we were used, well, Vagrant to do the thing, but back then the hypervisors did not have real APIs, okay? Yes, of course, you could code. I was doing back then some tests with the VMware API, and I think the VirtualBox API, and it was more annoying than useful, okay? And of course, we lacked programmable load balancing solutions, okay? You had to go to your engines and modify the configuration file to add more nodes and such, okay? We did not reach there. But for development environments, it was not very important. And, well, of course, the usage of VMs make us the possibility to offer the same hardware to a lot of different projects, each of them using different virtual machines and completely isolated from one to another. So this approach, I think, when in the time it was done, it was kind of visionary, and but it had some problems, of course. The virtual machines were very big. The extra takeout on resources was huge, okay? And they are very slow to start, and we use them to start some virtual machines to deploy the applications and then launch the functional testing to them, and then we delete the virtual machines to leave space to another projects, okay? And that took around 20-25 minutes for a very, very small app, okay? So, and of course, we were able to manipulate all the infrastructure, okay, with programmable interfaces. So we iterated through this. We elaborated cookbooks, we elaborated new background files, new background boxes, and such. And then something started to gain traction, okay, which was the center of our second approach. This thing was this software, what was gaining traction, was called Docker, okay? And you might have here talk about it. And it changed everything, at least in our ALM world, okay? So, and after it changed, and it continued to change all how the infrastructure is being managed, okay? So the point is that if we have Docker, then we have everything. It was so important that for me, I consider my career, okay, with BD and AD. So I had the before Docker and the after Docker periods of my life. And so, well, we remade all the pipeline with Docker containers, of course, okay? The same, infrastructure as code, of course. We began with Docker itself, then with Docker Swarm, and then we very early adopted Kubernetes, okay, inside the company, and we never looked back. So we started working with Kubernetes with the 1.0 version when it didn't have an ingress controller back then, and it was already awesome. And now, which is, I think, in version 1.10, which is going to appear right now, or it has appeared, it's more or less. Then they have incorporated a lot of things, and they have a very enormous community trying to become compatible with Kubernetes, okay? Which is, I think, it's the best of its assets. So the point is that it's so best that the Docker, in the new version, they switched to Kubernetes for Swarm orchestration, okay? And this dragged a lot of things behind, okay? Like development of software-defined networkings, like available, so you have programmable networks, programmable load balancers, programmable, everything began to be programmable after Docker and Kubernetes began to shake the market, okay? So, of course, if you are using Docker containers, we have immutable infrastructure and perfect immutable infrastructure, okay? At the same time, Jenkins, who didn't resign didn't submit to be left behind by the new continuous integration servers that were appearing, created the pipeline plugin, where with a Groovy file, you can define all your steps in your pipeline. So for us, it was perfect, okay? We know Groovy, so it's perfect. And the usage of Docker made us the possibility to share more infrastructure, or less infrastructure, between more projects. So it was awesome. This was like 2 years ago, okay? We went to the customers with this. We had some projects. We built Kubernetes production-ready clusters. We deployed it. They are currently in production. We are operating them. And everyone is very happy. Most of them, the operators. Okay? And we achieved everything we could not do with the virtual machine approach, and then we achieved more. Okay? We could build in a reasonable amount of time. We could do testing without, like, starting the application takes the same time that starting the container. And we also changed our mind about versioning, okay? Where we were working with Java, okay? And we keep a very strict versioning process for the artifacts generated, the jars and the wars. And then we started to ditch that. We were not generating Java versions for the war artifacts, okay? Or the new jar 12-factor applications with Spring Boot or whatever. And we started to version the Kubernetes, the Docker images. Okay? So a version of the application is not just the war or the jar or the application binary. It's the application binary with all the dependencies embedded. And when you generate a version of that, then that would never change. And if it works in pre-production, it of course will work in production. Okay? But we have a couple of drawbacks. Okay? Kubernetes back then did not have a role-based access control, which now has, but then it was not. And we could not manage multi-tenancy. Okay? So the developers could not enter Kubernetes to deploy their applications because they will be admins of the platform, and then they could do everything on the other projects, so we are not getting any isolation. And this was so this limited us the usage of Kubernetes as a deployment platform, not as a development platform. Okay, so it was very useful for testing and for something like that, but not for the developers to go enter and provision their own infrastructure, for example. So, and of course, if you have that issue, you have experienced that issue, is, well, when you deploy a Jenkins on your Docker container, on your Docker orchestrator, it needs, and you want to create Docker containers, okay, you have a little problem because it is inside a Docker container itself. So the first approach we always take is the famous Docker in Docker thing, okay, which is, well, you can create a Docker container with a Docker daemon inside, and then you can create like 2 layers of images, okay? So there was a guy from Docker who developed this functionality, the Docker in Docker functionality, Jerome Etienne, which says, don't do it. It will lead to layer corruption, and it will go wrong, okay? So we need to go through another approach, which is just mounting the Docker daemon of the host on our Docker container, so the Docker container does not create child Docker containers, but siblings. Okay? This is an issue. That Docker container needs privileged access to the node to be able to mount that socket. Okay? And then it makes that the Jenkins machine deployed inside a cluster of Kubernetes, inside a privileged Docker container. Well, we have seen recently some security talks, but it's not very wise. Okay? So we went one step further, okay? Our final approach. And our final approach was finally OpenShift, okay? OpenShift is a platform as a service software, okay? It's developed by Red Hat, it's completely open source and free, as in free beer. as everything Red Hat does. It has an enterprise version and an origin version, but it's exactly the same software. Okay, the only difference is that the enterprise version is supported and the origin version is not. Okay, but you can download it and start using like if you did it. And it's currently the version 3, okay? Because for version 2 they had a virtual machine approach. Okay, so OpenShift enters. Well, it's you can imagine itself as an enterprise level, a development layer over Kubernetes. Okay, so they implemented all the features of Kubernetes that could be cool, but Kubernetes has not yet implemented. For example, the role-based access control, or a more elaborated ingress controller, which they call router, and also they add a lot of new Kubernetes objects, which are OpenShift objects, okay, over Kubernetes, like the deployment config, the image stream, the build config, okay. And they also provide a Docker registry with a notification app API where you can subscribe and you can know, your applications can know when someone is pushing new Docker images to the registry, which is very, very useful. And they have developed some Jenkins plugins that integrates Jenkins perfectly with OpenShift, okay? So for us, at the first sight, it was perfect. So that plugins, okay, of OpenShift are like this one, okay, where you do not need to manage Jenkins users, but it integrates with the OAuth server that OpenShift already has, and then all the users can log into that Jenkins with the permissions assigned in the OpenShift cluster. Okay, so keeping the role-based access control you implemented before. So it's really nice because you can create a project with only view access, and all the people who have access could see the pipelines but could not modify them. They have also pipeline integration, okay? So we have this nice kind of interface where the Jenkins, they gather information from Jenkins and show you in the OpenShift console, so you don't have to go to Jenkins, which is, well, it's one of the most useless features of the OpenShift Jenkins integration, and it's probably the one I love most, because the UI of Jenkins is not the prettiest thing in the world, and this one is, well, some more pretty, okay? And you can also launch the pipelines from here. Taking account that the Jenkins they provide, it's also using the Kubernetes plugin. So basically every build is done with a Docker container, okay, which is instantiated on the OpenShift cluster. So a Jenkins instance could possibly escalate almost infinitely, because it will never run out of resources, because it does not run the load inside it, but in different containers, okay? So, and this is a very, very nice feature which permits us to keep really pipelines as code, okay? Normally, traditionally, the Jenkins file that contains the pipeline in Groovy goes alongside the source code of the application, okay? And that, it was nice, but I didn't like it very much, because, you know, it's not part of the application. It's part of the configuration. And with this, okay, with an object of build config type pipeline, we can develop, well, Groovy pipelines and embed it into OpenShift as if we are creating objects. And the last functionality, which is critical, is the possibility of using the OpenShift Builder API to build Docker containers. So then the Jenkins container does not need to be privileged anymore. Okay? It just needs to request OpenShift with this kind of API language, okay, to build the container for you. And then OpenShift will build the container itself with its privileged permissions, which you don't have access to, and it will give you back the container. Normally, it will push it to an image registry. Okay. So, if you don't mind, we are going to see a little bit of OpenShift in working. Okay, so you can get a little taste. So, this is the, okay. So here we have the web console of OpenShift, which is also a big improvement over Kubernetes, okay? Because Kubernetes has a console, but really, that's a console. To put that, don't put anything. So this is I feel this is much more good. So, and they include a lot of feature of images that you can deploy out of the box, and they already work. So we have the catalog, okay? We have a whole lot of different containers of different images we can use to deploy our source code, okay? And in our case, we are going to try to deploy a Jenkins, okay? Because I want to build something, to use the pipelines and such. So, okay, everything is almost perfect, except this one, which 512 megabytes as a default for Jenkins. It's not... So, yeah, that's it. Two of the actions actually failed because they are all the service accounts, okay, which were created before, but it doesn't matter because it already creates all the rest of the infrastructure. So if we go to the project, we can see here that the deployment is running, and when the circles are dark blue, then we have our instance, okay? So, and this instance is accessible, or should be accessible, you know. We haven't done an offer to the demo gods, so I don't know if... Okay, here we have. I can log in Jenkins using my OpenShift password, okay? And we have nothing. We have just the demo pipeline from the sample pipeline, okay? Which comes. It has, as I am saying, a lot of different plugins installed and such. But we don't need to worry about that. We only need to use it, okay? So now, if I was a developer trying to use this, so I want to build my code, okay? So we have here the builds, the pipelines. We have no pipelines, of course. We have not created anything. And to create a pipeline, we can use the OC tool, which is, if you have used Kubernetes, is exactly the same as the kubectl, but with some extensions to be able to manage OpenShift objects. So, for example, if I try to go and query the nodes to see how the cluster is configured, the internet is not very good here, so if you haven't noticed. Well, I don't have permissions, okay, to list all the nodes in the cluster. This is a pretty good advantage, or this was a pretty good advantage over the Kubernetes usage, at least for us. Now, I think from Kubernetes 1.7, this is also incorporated. They basically copied the role-based access control system from Red Hat, or it was contributed by them. I don't know, okay? They are not competing right now. But, well, I could list the pods. Okay, I have my Jenkins pod, and I have here my pipeline. Okay, it's the most beautiful pipeline in the world, which does a lot of things, like greeting you all, which are the most beautiful people in the world. And the point is that this line is telling that it's going to use our Maven building node for doing that. So these stages could be just Java, for example, compilations or something like that. Okay. So apply. So if we apply the pipeline, it will create the build config of type pipeline. So we can see it here. And also, okay, it has created it in Jenkins. So now we could operate this Jenkins completely separately from OpenShift, and it will be nice. Okay, we can launch the pipeline from here. We can no, don't modify the pipeline from Jenkins, of course. But well, but it's more cool if we do it through here, right? So we just need to start the pipeline. As you can see, well, it started on Jenkins. We have a direct. This is not very good integrated, the logging thing, but I think they are making improvements. This is not the last version of OpenShift. Okay, so the pipeline ran, and now, well, in OpenShift, well, we have the hello. We could edit the pipeline if we wanted to add more steps. Don't do this. The pipelines should be always reflected in the YAML files because we are using infrastructure as code. And it should be saved on, well, on Git or whatever. Okay. So what if I want? No, I want to pass Sonar analysis. Okay, no problem. The developer comes to the catalog and can deploy Sonar Cube, which we can select the version, the volume capacity, so because this is going to store configuration. Okay, so this is the same. The service account was already created. No, not found. Okay, yes. We have a problem with. But the point is that we go. Okay. Well. Okay. So the point is that it keeps creating things over the things that are not yet created. Okay. It's idempotent, a word that I like very much, and I remember yesterday during the last of the talks. Okay. So. Let's get back. Nope. Okay. So, well, this is mostly a little set of functionalities OpenShift offers to develop, to be used as a development application, okay, as a development platform. You can ask me questions. I think we have a little spare time because this talk started a little bit late. And, well, you can watch me on Twitter or I don't know. Any questions?